All right, folks, it's back in action here. We're going to do our last video of the semester, and we're going to solve a system of 3 variables using Cramer's rule. So this will give us a third technique for solving systems of 3 variables. You could apply this to a system of 2 variables as well, but I'm just going to walk through the system of 3 since it's our most complicated version. The first thing we want to do in using Cramer's rule is we want to write the coefficient matrix. So I'm going to write that. I'm going to have a 2, 1, or 1, 2, 1. Sorry, I got ahead of myself there. 2, negative 1, 3, 2, negative 3, negative 5. And then we're going to use that to find the determinant of that coefficient matrix, that 3 by 3 matrix. Now, finding the determinant requires us to follow a little bit of a formula here. So what we're going to do is we're going to grab the 1 that's on the top row. So I'm going to grab that 1, and then I'm going to ignore some parts. So I'm going to pretend that this column's not here and this row's not here, and I would be left with this 2 by 2 matrix. So I'm going to write that out. So I'm going to have a negative 1, a 3, a negative 3, and a negative 5. Now in my next step, I want to remember that the next step has to be a subtraction. It always has to be a subtraction there. Then I'm going to grab the 2 that's at the top, and I'm going to put that there. And again, I'm going to ignore some columns and rows. So now I'm going to ignore this column and still ignore the top, and I'm left with the 2 by 2 matrix. So I'm going to write that matrix. So that's going to be a 2, a 2, a 3, and a negative 5. And then I can go on, and I'm going to grab the 1 that's in the top right corner there. So, and I'm going to go back to a plus. And when I look at that one, I am going to ignore this column and this row, and now I'm going to be left with this little matrix, this 2 by 2 right here. So I'm going to write that one. And I'll have a 2, and a 2, and a negative 1, and a negative 3. Now what I'm going to do is I'm going to go back and I'm going to find the determinant of each of those 2 by 2 matrices. So we're just going to follow our same process. So starting back here at the beginning of this, I'll have a 1. And when I do the determinant, it's this product minus this product. So I'm going to have a 5 plus a 9, because I'm subtracting a negative 9. Then I'm going to still have my negative 2. And then I'll have a negative 10. Minus a 6, and then I'll have my plus 1, and I'll have a negative 6, and it's going to be plus a 2 because I'm subtracting a negative. Now I can start to clean that up. So I'll have my 1, and certainly you'll be able to simplify some of these steps and skip some in a little while. And then I have my negative 2 minus my 16 plus my 1 times a negative 4. And now I can clean all that up. I'm going to have a 14 plus a 32 minus a 4. Simplifying that whole value is a 42. That 42 is the determinant of the coefficient matrix, and we're going to use that in a little bit. Now, I'm going to start to skip some of these steps. We're going to go a little bit faster as we go through this. What we're going to do is we're going to solve for a variable. So I'm going to choose to solve for x. Okay, that's what I'm going to solve for first. I could choose any variable. It's not going to matter. Now, this gets a little bit tricky. What we're going to do is we're going to replace the first column of the coefficient matrix with the constants. So since I'm solving for x, I find the column that represents the x's, and I replace it with the constants. So my matrix, my 3 by 3 matrix, now looks like a 10. Sorry about that. It looks like a 10, and then a negative 5, and a 27, and then the rest of the coefficient matrix just gets rewritten. 2, negative 1, negative 3, 1, 3, negative 5. Now what I'm going to do is I'm going to find the determinant of that 3 by 3 matrix. So I'm going to go through the same process that I did before. I'll probably write a little bit less this time. So I'm going to have a 10, and it's going to be times, instead of rewriting the whole by 2 by 2, I'm going to just show you. It's going to be the 10, and then I'm going to do the determinant of this little matrix. So 5 minus this negative 9. So I'm going to write 5 plus 9. Then I'm going to do 2. And now I'm going to do the determinant of this 2 by 2 matrix. So a 5 times a 5, there's my 25, minus the 3 times the 27, or 81. I'm going to go back to a plus, and I'm now going to do a 1, and I'm looking at this 2 by 2 matrix, so 15 plus 27. Just like before, I can start cleaning that up. I'm going to have a 10 times a 14 minus my 2 times a negative 56. Certainly you could skip some of these steps, plus my 1, and then this time I'm not going to write the 1, I'm just going to write the 42. So I have 140. Now I'm going to have plus 112. You got to be really careful with signs. Plus 42. So the determinant of this, what I would call the X matrix, is 294. So our answer for X then simply becomes X equals, I'm going to take that 294, and I'm going to divide it by the determinant of the original coefficient matrix, which was 42, and that equals 7. So now we just solved for X. Now we're going to repeat that process, and we're going to solve for Y. So in this step, we replaced the first column of the coefficient matrix with the constants because that was the X. This time I'm going to replace them in the second column because that's where my Y's would appear. So now my matrix that I'm going to work with is going to be a 1, a 2, and a 2, the original column from the coefficient matrix. Sorry, stumbling over myself. Then I'm going to replace the second column with the constants, 10, negative 5, 27. And then I'm going to still keep the third column, 1, 3, negative 5. And I'm going to repeat the process. I'm going to find the determinant for this matrix. So I'm going to do a 1, and I'm going to have a 25 minus an 81. So remember, that's this 1 times the determinant of that little 2 by 2. Minus, don't forget that minus, I can't emphasize it enough. Now I'm going to have a 10, and it's going to be times a negative 10 minus my 6. So negative 10 minus 6. And then I'm going to have plus, I still have the 1 there, and I'm going to have 54 minus a negative 10, or in other words, plus a 10. So I have a negative 56 plus a 160. I'm skipping some steps now because I want you to see that we don't have to write out quite so much. Plus my 64. When I clean all that up, the determinant of what I would call the Y matrix is a 168. So my answer for Y is going to be 168 over the determinant of the coefficient matrix. So Y turns out to be 4. Now, once you have two variables, just like we've seen in the past, we can take those two variables and substitute them into any of the original equations that we want. I am going to choose to work with the very first equation, so I'm going to have an x plus a 2y plus a z equals a 10. So I'm going to sub those in. So my x was 7. My y was 4, so I'll have 2 times 4. Z is what I'm still solving for, is 10. So I get that z equals a negative 5. And then, of course, we could write this as its full ordered triple of 7, 4, negative 5. All right, that's Cramer's rule. It's a lot of little tiny steps. It's a little tedious, but a little less thinking, and might be nice for some of you who like a process, one that always has a clear process for you.